So therefore, give me a second. Guys, if I'm muted, you should able to tell me, right? You're horrible. Okay, doesn't matter. So next question will go further. Consider the following reaction according to the nucleophilic substitution reaction of alkyl halides. And I have given the two type of the reaction. CBr, CH3, hydrogen, hydrogen. When it react with OH minus, this is reaction 1. The second question, CH3, CH2, CH3, CH3, Br, which is react towards reaction 2. So what is happening here? The question is, what are the products in reaction 1 and 2? Give me a second, guys. I'll do that. Ma?
CH2 CH CH3 CH3O plus Br minus. Madam, you are mute.
So wait, then I'll come. Just wait. Okay, sorry guys. Yes. So what should be the reaction? So here I'm talking about what the alkyl. Okay. So when he speaks about this, yeah, it's a both will give the nucleophilic substitution reaction. So you have to understand the difference. That's why I have given the reaction between this. So what should be the answer? So your question is you have to find the product, right? So yeah, Zain, you said me the answer. What is the answer? The first step is you will end up with CH3, hydrogen, hydrogen, OH minus, OH, Br minus. And what should be the answer for this reaction? Yes? CH3, CH2, CH3, CH3, and this is also OH, Br minus. Are you all clear about these products? Yeah, Shahid, is it clear? Yes?
Yeah.
Okay. So your next question is, you have to write the reaction mechanism. Can you say what is the difference between the reaction 1 and the reaction 2? Can you say what is the difference between the reaction 1 and the reaction 2? Yes, guys. Yes, guys. What is the difference? You are able to say. Why the reaction mechanism is changes in between these both are alkyl halides. It's reacting towards the OH minus, having the same time of the answer. Why this is the reaction difference is, this is the primary alkyl halide. This is tertiary alkyl. So the primary alkyl halide,
Miss,
yes,
primary means there must be 3 hydrogen, no?
yeah, 2 hydrogen. How can be 3? Alkyl halide means you will have one CX bond, right? You will be have the one CX bond, right? With that, definitely you will have the one alkyl group along with 2 hydrogen. That is the primary.
Okay.
So again, the secondary, you will have the 2 R group with 1 hydrogen. Tertiary means all are R group, right? So this is a primary alkyl halide, this is the tertiary alkyl halide. Always the primary alkyl halide, only one step reaction. When you go for the tertiary alkyl halide, you will end up with this 2-step reaction. This is the difference, major difference between what that 2 reactions. So I will write the mechanism, and they ask what is the major difference in above mechanism of reaction 1 and 2, right? So you would be able to say the reason is, let's rewrite. The major difference is, I say the reaction 1 is one step reaction. One step reaction. So what is mean by the one step reaction? The bond breaking and the bond forming will take place in one step. That is the one step reaction. So what is the reaction 2? It's having the 2-step reaction. Why is a 2-step reaction? First, what will be happen? The bond breaking, the CX bond breaking will happen. Second step, yes. Now the break is finished. Now the C nuclear bond forming will happen the 2 steps. That is the major difference. Again, I am just prescribing you all. Okay. So the first step is, we said the primary alkyl halide. So the primary alkyl halide, the bond breaking and the bond formation will take in a one step simultaneously, right? So when you go for the 2-step reaction, or the reaction 2 that is having the 2 steps, because what, that is the tertiary alkyl halides, right? When you have the tertiary alkyl halides, you will end up with the two steps. The first step is your CX bond, yeah, your CCl, CBr, CI bond will break, and the second step, the C nuclei bond, the new bond will form. So this is what the major difference between the step 1 and step 2, right? And you can speak about this, the stability of the products. All were given here. Before that, let's rewrite the reaction mechanism. So your first reaction is your CH3 Br hydrogen, which is react with OH minus. So let's write the reaction. The OH minus. Right. Okay, when it's react with. Okay, when this nuclear attach and this will form. So what is happening? The bond breaking happens as well as the new bond formation. It happens in one step because this is the primary alkyl halide. So you will end up with CH3. Yes. And here you will end up with this will break and this is attached. Your hydrogen is here. This is here. And this is OH. This is one step. This is for the reaction one. And you will end up with what? Okay. The substituent of the OH group for the alkyl halide. Right. And go for the next question. Where the reaction takes place. Just give me a second. Okay, sorry guys. And go for the next. CH3, CH2, CH2, CR, So what is happening here? The first step is bond breakage will happen. So you can write this as CH2, CH3, Br will build. And it will form the most stable carbocation plus CH2, CH3, CH3, CH3. This most stable, this is the one step. And next step, what will be happen? The OH minus cleaved OH, the OH minus will attach to this OH plus. And now you will end up with what? So this is what? Converting the bond breaking. Convert to what? Towards the carbocation. It's the first step. Then your second step, forming of the new bond. Bond formation. Formation with carbon OH group, carbon nucleus. And this is what we are calling. Are you all clear? So this is your responsibility. Once you understand the alkyl halide structure, and you have to determine whether it's a one-step reaction or two-step reaction. If it is a one-step reaction, it's simultaneously bond formation and the bond cleavage will arise. The two-step reaction, first the formation of the carbocation, and then what? The nuclear bond is formed. Right? Okay? Fine. I didn't teach you. Right? Did you all understand? Did you all understand? Is it clear? Guys, is it clear?
Miss Ashit.
Sorry?
No, Miss process.
Yeah. Process.
Okay.
Okay, right. Whenever you speak, you want to perform any reaction with the alkyl halide, first you have to check the type of the alkyl halide, whether it's a primary, secondary, tertiary. If it is a primary, it's always the one-step reaction. The secondary, tertiary, we go for the two-step reaction. Right? The tertiary is more towards the two-step reaction than the secondary. Why? And your last question, comment the product stability of the reaction 1 and 2. Yes, your reaction 1 and 2, you can say about the stability. Yes, the tertiary alkyl halide will go the reaction in the two step. Why? They are tertiary alkyl halide able to form the stable carbocation. Tertiary carbocation, which is more stable compared with your primary alkyl halide than your secondary alkyl halide. So the stability, again and again, the same thing that I am repeating, right? If you understand, you are able to realize. Yes, when you speak about this stability, we always speak the tertiary carbocation. So simply you can say this higher stability shown by the tertiary carbocation. Therefore, your reaction to have the more stable product than the reaction one. Are you clear? Are you all clear?
Clear.
Thank you. That's okay, fine guys. So we have done the fortnight examination paper, and that is not that much hard. I want to give you different type of the reaction which is able to go for the alkyl halides. There is another type of the reaction. If you go through the notes, right, you will able to understand, right? So if you use in the alkyl halides, right? When the alkyl halides react with any base, one thing they are able to undergo for the nucleophilic substitution. Other thing they are able to undergo for the elimination reaction. That is another type of the question. I didn't ask. At least to try that question. So according to the reagent condition, it will determine whether it's a nucleophilic substitution or elimination. If it is a strong, right? So we have the notes is there. When you use the ethanolic KOH, we are telling it able to undergo for the elimination, the removal of the water molecule. So aqueous KOH, you can go for the nucleophilic substitution. We have studied. So this is the different type of the alkyl halides able to form the reaction. Are you all clear? Are you all clear? Right? Okay, we have completed the question paper. This is really easy question, right? Okay, so I will share. We have done the aldehyde halides. Sorry, aldehyde ketone. So now we have to do. Give me a second. I'll share. Okay. Mm, okay, on the line and take your presentation, which is shared in your MS Teams also. Take the carboxylic acid. Okay, we are going to speak about this. Have you all received it? Okay,
Which one, miss?
I have sent another presentation. Carboxylic acid
Ah, yes,
and
in
the
MS Team it
derivatives.
was there.
MS Team it was there, and now I just send the reaction of the carboxyl. I sent through the WhatsApp also. Right? Okay. We have 21. Okay. So we can do actually. Yes, at least we can complete what today is the physical properties of the carboxylic acid. At least we can speak about that. Okay, you can leave the presentation. The presentation is there. It's alright. So take the printout. So this term I'm just going to finish with what the up to carboxylic acid. And next week, guys, we don't have exam, so we don't have school. So the week which is going to be start that week, I will keep another exam. The monthly end exam should be there. Okay, so end of the July you will be have the exam, so be prepared with that exam. Study and come. Definitely, please study and come. I
Is there
just
no holiday?
not this week, following week, not coming week, following week. That means the date is 26. You will have the exam. So we have another 4 days. That is well enough to complete this carboxylic acid. Okay, and we'll do some revisions, which will check the past paper. If there is any MCQs belongs to the we'll check, right? If not, I'll keep the quizzes. That should be good, right? We'll make at least the quiz to do the MCQ setup, what we studied up to the carboxylic acid. Right? For the following week, our last week will based on the revision once I complete the carboxylic acid presentation. Are you all clear? Right? Fine?
Yes, miss.
So now, having so many work is mine is not working. Okay, right. Now let's we move on to the properties of the structure and the properties of the carboxylic acid. Can you say what is the functional group of the carboxylic acid? Yes, you can write on the board. Yes.
Miss, I can't write. Can I say?
Okay, take.
COOH. C double bond O, up and down O, and again bond H.
So when you have the carboxylic acid, we are talking about what? C double bond O, and we have the angle here. Okay? Right? That is called the carboxylic acid. So what is the mention is when the carboxylic acid, right? We are talking with simply it's having what? The COOH bond. Here you should be able to understand you have the carbonyl carbon and the OH group. The combination of this we are calling as the carboxylic acid. This is your structure. Right. Fine. I will share the presentation. Structure and the properties reaction of the carboxylic acid. Right. So when you want to speak about the carboxylic acid, these are the contents. Here just we are going to speak about that just for the intro, guys. Right. And just will do. The first step is each and everywhere you are able to understand the physical properties. What we are studying under physical properties. What type of the bond that carboxylic acid can be shown. Because of this bond, what type of the attraction is there? Therefore, you can speak about what the boiling point and the water solubility. This is what continuously we were studying from the beginning. From alkene, alkyne, and next the alcohol, right? Your alkyl halides, yes. Okay, your benzene, phenol. Now we have stepped into what? The carboxylic acid, the physical properties. The same like a tabulation, we will study that one. Next one, we are going to speak about the comparison of reactivity pattern of CO group with carbonyl group aldehyde and ketones and the OH group in alcohol and phenol. Why we are doing this such kind of the comparison? When I speak about this carboxylic acid, you have what? The carbonyl group as well as the OH group. Right, this is what one type of the group, it's a OH, and another one is what? The carboxylic group. So when you speak such kind of the group, this seems to be similar like your aldehyde ketone. When you speak about the aldehyde and ketone, that is having the carbon and carbon group, and this is the OH group seems to be similar like your alcohol and phenol. Did you all understand? So that we are going to do a comparison of the reaction pattern of the carboxylic group with your aldehyde ketones and the alcohol phenol. And you can see here the reaction involving the cleavage of the OH group, the cleavage of the CO bond, and the reduction of the lithium aluminum hydride. This is what we are going to study under carboxylic acid. And next step is we are going to speak about the carboxylic acid derivatives. Actually, I have spoke about this carboxylic acid derivatives. Yes. The carboxylic acid, they able to possess three type of the derivatives. This is your original carboxylic acid. If you are going to substitute another alkoxy group, that is we are telling ester. If you are going to substitute amine group, that is we are calling amine. If you are going to substitute acid group, we are calling this is as a acid chloride. And these are what we are going to study here. Ester, amine, acid chloride. So here the carboxylic acid, the reaction of the acid chloride, the reaction of the ester, and your down group which shows the reaction of the amine. These three we are going to study in the different manner, right? And your acid chloride able to process different type of the reaction. Again you have the work, we have to construct the short notes. This is very important. You have the plenty of the reactions. So for that sake, to determine the differentiation between what is the happening in your acid chloride ester and amine, you're able to write the reaction in a different way. Right? Are you all clear, guys? Let's move on to the reaction, the first step with the physical properties. Are you all clear? Yes, guys?
Okay.
Give me a second. I just put something clear all the. Guys, I think you have another 2 minutes, right? Once it's finished, rejoin the class, right? Okay, guys. I just want to find stamps, question mark, arrow, the black color background. Otherwise, I have to use the presentation. Okay, right. So let's we move on to the. I'm just start. Okay, we have spoke about this, and next we are going to introduce the structure of the carboxylic acid. I have said yes, when the carboxylic acid compared with other acid is a more acidic than the organic compound having the OH group, but weaker than the common mineral acid. This is very important. When you speaks about the acidity, right? You have the alcohol. We said the alcohol acidity less than the phenol. We studied. And those OH group containing group, it shows weaker acidity than the carboxylic acid. But this acidity is less than the mineral acid. What should be your mineral acids? HCl, H2SO4, the acid usually we are using. Those are the acids. So when you speak about the acidity, your carboxylic acid is able to possess, right, acid activities. Comparatively, it's higher than your alcohol containing organic or OH containing organic group, and it's less than what the mineral acid. Right. Okay.